So for homework assignment number 10, you are asked to complete exercises 6.2 on page 155, problems 1 through 12. And for these exercises, what you are asked to do is you are given two categorical propositions, and you are asked to assume that the first one is true. And given that the first categorical proposition is true, you had to determine if the second proposition is true, false, undetermined within the square by using the traditional square of opposition. So beginning with problem number 1, assume that the first proposition, all S or P, is true. What can we know for certainty about the second proposition, some S or P? Is it true, false, or undetermined according to the square of opposition? And with this, the second proposition would be true. So, some S or P is the subalternate of all S or P. Number 2, all S or P. If that is true, then what can we know for certainty about no S is P? Is it true, false, or undetermined? If all S or P is true, then no S or P is, according to the traditional square of opposition, false. These two propositions are contrary. They cannot both be true at the same time. Number 3, assume no S is P is true. Assume it is true. Then what is the truth of all S or P? And it is also false. Again, these are contrary propositions, meaning they cannot both be true at the same time. Assume some S or P is true, then what can we know about the truth of all S or P? And the answer is we can't know whether or not it is true or false. After all, some S or P might be true due to the fact that all S or P is true. However, it may also be true because some S are P and some S are not P, in which case all S or P would be false. So with this one, we cannot know whether or not all S or P is true just based on the fact that some S or P is true. Again, these are subalternates, and if you look at the traditional square of opposition, you see that the arrow points down. That means the arrow goes with truth. If A is true, A form proposition is true, then an I form proposition is going to be true. But the arrow doesn't go up in that way. Number 5, some S are not P. If this is true, then all S or P is false. These are contradictory propositions. And remember, when you're dealing with contradictory propositions, these have the exact opposite truth value. If one is true, the other is false. If one is false, the other is true. No S is P. If this is true, then some S or P would also be false because these two are contradictory propositions. Again, if one has the truth value of true, the other is false. If one is false, the other is true. Contradictory. They cancel each other out. Assume some S are not P. If this is the case, then the truth value of no S or P is undetermined. Some S are not P. Now this might be true because it is also true that no S is P, in which case no S or P would be true. But it also may be true because some S are not P and some S are P, in which case no S is P would be false. All S are P. If this is true, if we assume it's true, then it is false that some S are not P. Again, these are contradictory propositions. In fact, if you look right here, number 8 and number 5, the problems just reverse the propositions we're dealing with. But as I said when I discussed number 5, when you're dealing with contradictory propositions, if one is true, the other is false, and vice versa. Some S are P. If this is true, then we cannot know the truth value of some S or not P. After all, if some S or P is true, this might be true because all S are P, in which case some S or not P would be false. But it also might be true because some S are P and some S are not. These are what we call sub-contrary propositions. So with one of these, just because one is true doesn't mean the other is false. However, and I pointed this out a long time ago, if one is false, if some S or P, if we had assumed that was false, then it would actually follow that some S or not P would be true. So while the truth of one of these propositions doesn't tell you what the truth of the other one is, the falsity of one of them does tell you what the truth of the other one is, or I should say the truth value. Some S are P. If we assume this is true, then no S is P would be false. Again, these are contradictory propositions. And if they're contradictory, that means if one is true, the other is false, and if one is false, the other is true. Some S are not P. If this is true, then we cannot know the truth value of some S are P. This is just the mirror opposite of problem number 9 stated 2 problems ago. When we're dealing with sub-contrary propositions, as I said a moment ago, if we assume that one of the propositions is true, or we know that one of the propositions is true when we're dealing with sub-contraries, that doesn't enable us or give us enough information to determine whether or not, or what the truth value of the other sub-contrary proposition is. However, if one of them is false, it does give us enough information to determine the truth value of the other sub-contrary proposition. No S is P. If we assume this is true, then it follows that some S are not P. So some S are not P would be true. And the reason for this, you can go back to studying the traditional square of opposition, but these are subalternates of one another. And as you can look on the table above on page 155, if an E-form proposition is true, the arrow points down and truth goes with the arrow. So you know that if the E-form proposition is true, then it follows of necessity that the O-form proposition is also true. Now, this was a pretty quick homework assignment, but if you have any questions, please email me. I know some of this can get a little tricky at times, but if you follow the square of opposition around and take your time, I think you can probably answer most of these.